Hello everyone, we are RGA Tutorials. In today's video we're going to be doing a part 2 of atomic structure. Alright, we can start.
Okay, so in the case of Mg2 plus ion, magnesium, it's got an atomic number of 12, so when it's got a positive sign, it has lost electrons. So now it's at 12 protons. The carbon changes, but the number of protons don't change. Now in the case of a carbon atom naturally has 6 as its atomic number. Now in the case of an unknown element X, it's got a mass number, so A is equal to 63. It's got a neutron number of 34. To get the atomic number, which is denoted as Z in the notation AZ, where this is the atomic number, remember, and this is the mass number. Z is equal to A minus N. So Z is equal to 63 minus 34, and that gives us 29 protons. I hope you understood everything. Okay. Now on to electrons. So now electrons. So in an atom that is neutral, as in it has a positively charged nucleus, so it has positively charged protons and negatively charged electrons in orbit around the positively charged nucleus. Well, obviously the electrons are negatively charged. Now we're just going to go over types of ions like we've already previously said. So ions, they have different numbers of electrons to their atomic number, that is the number of protons, depending on the charge. So a positively charged ion has lost electrons and therefore has fewer electrons than protons, whereas a negatively charged ion has gained electrons and therefore has more electrons than protons. Okay, another worked example. So you may want to pause this so you can see if you can attempt this by yourself. Then we'll go over to the answers. All right. Okay, so now in the case of Mg2 plus ions, how many electrons does an Mg2 plus ion have? Remember we said in the case of a positively charged electron, so plus, it has lost electrons ultimately. So it's going to have 12 protons, but 12 minus 2, because it's lost 2 electrons, is equal to 10 electrons. In the case of a carbon atom right here is neutral, so no positive or negative charge. The protons which are positively charged cancel out the electrons which are negatively charged. So for this case, where it has an atomic number 6, so 6 protons, it's going to have 6 electrons as well. Now in the case of an unknown element X, which we know has 29 protons, since it's neutral, we know that it's going to have how many electrons? 20. Okay. Now, on to neutrons. Okay, so now the massive atomic numbers, they can be used to find the number of neutrons in an ion or an atom. So now it's important to know that the number of neutrons is equal to mass number, so A, minus the number of protons, Z. So on to our last worked example. You can pause the video to see if you can attempt this. Now on to the answers. So in the case of an ion Mg2+, which has 12 protons and 10 electrons, it's going to have how many neutrons? So now magnesium has a mass number of 24, so 24 minus 12 is equal to 12, so it's got 12 neutrons. In the case of a carbon atom, which has a mass number of 12, but an atomic number of 6, it's going to have 6 neutrons. And in the case of an unknown element X, which has got a mass number of 63 and 20, it's going to have 34 neutrons. Okay. Now on to isotopy. So now isotopes, they're atoms of the same element with the same number of protons and electrons, but they've got a different number of neutrons. So now the symbol for an isotope is the chemical symbol or a word followed by a dash, then the mass number. So now, for example, we could have something like, for isotope denotation, we could have something like carbon 12 to represent carbon 12, or carbon 14. Another way, however, would be to write it out completely. Carbon, then 12, carbon, $14. All right.
So remember we did say that isotopes have the same number of protons and electrons, but they've got a different number of neutrons. So let's go now in the case of protium, deuterium, and tritium. So protium has got 1 for its atomic number, so 1 proton, and 1 for its mass number, so it has no neutrons. So now in the case of deuterium, it's got 1 for its atomic number, so it's got 1 proton, and then for its mass number, it's got 2, so that means it's got 1 neutron and 1 proton. Remember, the neutron number always has to be different. That's what makes them isotopes.
In the case of tritium, it's got 3 for its mass number, it's got 2 neutrons and 1 proton. So now isotopes, they've got similar chemical properties, but they've got different physical properties. So now in the case of chemical properties, isotopes are the same element. They display the same chemical characteristics. Now, why is this? This is because they have the same number of electrons in their outer shell. And you guys, an important thing to remember for your exams is that the number of electrons basically determines the chemical property or the chemical reactions that an element is going to undergo. So now electrons, they take part in chemical reactions like I've just said, and therefore they determine the chemistry of an atom. Now in the case of physical properties which isotopes differ, this is due to their difference in the number of neutrons. So since the neutrons are neutral subatomic particles, they only add mass to the atom. As a result of this, isotopes have different physical properties such as small differences in their mass and their density. Now on to electronic structure. Alright, so for electronic structure, what are shells now, for instance? Shells are the arrangement of electrons in an atom. And the arrangement of shells in an atom is actually referred to as the electronic configuration of that atom. So now electrons are arranged around the nucleus in principal energy levels or principal quantum shells. Now principal quantum numbers are used to number the energy levels or quantum shells. Like we can see right here, these principal quantum numbers. So now the lower the principal quantum number, the lower it is, the closer the shell is to the nucleus. Like this shell right here is closer to the nucleus. And so the higher the principal quantum shell is, like n is equal to 4, the further away it is from the nucleus. And so the higher the energy level of the shell. So each principal quantum number has a fixed number of electrons it can hold. So for example, n equals 1 can hold a maximum of 2 electrons, n equals 2 can hold a maximum of 8 electrons, n equals 3 can hold a maximum of 18 electrons, n equals 4 can hold a maximum of 32 electrons. Okay, on to subshells. Alright, so for subshells, the principal quantum shells, they're split into subshells. So n equals 1, n equals 2, n equals 3, and n equals 4. These are all the principal quantum shells. They're split into subshells, right? And these subshells are given letters S, P, D, S, P, D, and F. So now elements with more than 57 electrons, usually transition elements, you're going to learn about that in A level, they've got electrons in their F shell. So now the energy of the electrons in the subshells, it increases in order of increases in energy from S to P to D. So now the order of subshells appears to overlap for the higher principal quantum shells as seen in the diagram here. So for example, when you have the order usually in electronic configuration for subshells would be 1s, 2s, 2p, 3s, then 3p. But instead of going 3d, we go 4sy. Because 3D has got a higher energy than 4s. So for this reason, 3D is going to come after 4s, not before it. Because 3D has a higher energy level, it's going to be kept further away from the nucleus. And because of this, it's going to be ordered after 4s in electronic configuration. Okay, now on to orbitals. So now subshells, so letters S, P, D, and F, they contain one or more atomic orbitals. So now orbitals exist as specific energy levels, and electrons can only be found at these specific levels, not in between them. I repeat, electrons can only be found at these specific levels, not in between them. So each atomic orbital can be occupied by a maximum of 2 electrons. This means that the number of orbitals in each subshell is as follows. So S right here has 1 orbital. So because it has 1 orbital, it can contain a maximum of 2 electrons. P has 3 orbitals. Well, the thing is, every atomic orbital actually can contain a maximum of 2 electrons. But S has 1 orbital, so it contains 2 electrons. P has 3 orbitals, so it contains 6 electrons. D has 5 orbitals, so it contains 10 electrons. And F has 7 orbitals, so it contains 14 electrons. Now, the orbitals can have a 3D shape. But just know that the shape of the d orbitals, they're not required at AS level, only for A level. So now on to ground state. So now the ground state is the most stable electronic configuration of an atom, which has the lowest amount of energy. So now this is achieved by filling the subshells of energy with the lowest energy first. So 1s, we know it's closest. 1s is in the subshell, n is equal to 1, and n is equal to 1 is a shell that's closest to the nucleus. So it has the lowest energy. So that's why it's going to be ordered first. Then we go on to 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, then 4p, probably 5s, then 4d, then 5p, then so on and so forth.
So we've now reached the end of this video. Thank you so much for watching, and make sure to tune in for part 3 of atomic structure, where we talk about ionization energy and electronic configuration.